Let's look at an example of the mean value theorem, or really more of a consequence of the mean value theorem. The mean value theorem says that if you have a continuous function and you're looking at points A and B, if you were to consider the slope of the average rate of change, that slope of the secant line, there's going to be some spot C such that f prime of C is equal to the slope of the tangent line, or the secant line there. So that's kind of an interesting result. So that means if you look at the average velocity over an interval, at some point you were going exactly that average velocity. So let's see what that looks like here for f of x equals 1 over x on the interval 2 to 10. So first thing I'm going to do is I'm going to find f of 2, which is 1 over 2, because my function is 1 over x, and f of 10. Again, my function is 1 over x, so this is 1 over 10. And now I'm going to go ahead and find the secant line, or rather, the slope of the secant line, the average rate of change. So the average rate of change is equal to my y value, 1 over 10, minus my other y value, 1 over 2, over my x values, 10 minus 2. y2 minus y1 over x2 minus x1. I'm going to multiply the top and bottom of this thing by 20. So I have 1 over 10 minus 1 over 2. 10 minus 2 is 8. But if I multiply the top and bottom by 20, or even just 10, we'll just do 10. Any sort of shared denominator, let's try to cancel out some of these fractions to see if we can come up with a nicer number. 10 over 10 minus 10 over 2 is equal to 8 times 10. This gives me 1. 10 over 10 is 1. Minus 5. 10 divided by 2 is 5. Over 80. 8 times 10 is 80. 1 minus 5 is negative 4, so I have negative 4 over 80, which is the same thing as negative 1 over 20 if I reduce. So the average rate of change is negative 1 over 20. And the mean value theorem says that there's going to be some spot between 2 and 10 that has this exact slope. So let's see if we can find it. F of x is equal to 1 over x, or x to the negative 1. So taking the derivative, this gives me that the derivative of f of x is negative x to the minus 2. If I use that power rule, power drops down, I change the sign there. I want to set this equal to this negative 1 over 20 and solve for a particular value. So let's say that I know my derivative is negative 1 over 20. Let's solve for x. I have negatives on both sides, so I can cancel those negatives out. I have 1 over 20 equals x to the minus 2. X to the minus 2 is really 1 over x squared. If I cross multiply or think about flipping those fractions, this gives me that x squared is equal to 20. Finally, to get x by itself, I take the square root of this and I get x is equal to the square root of 20. Really, it's plus or minus the square root of 20. So I have plus or minus, typing this into my calculator to get a decimal so it can at least approximate what's going on here. 4.47 or so. Now, I was looking on the interval 2 to 10, so this tells me in particular at x equals positive square root of 20, or 2 root 5 for those of you that like to simplify your radicals, we achieve the average rate of change. So I was guaranteed that such a value exists. We found that value that had to exist. It was 2 root 5.